Have you ever wondered why corn syrup sinks inside water but the oil floats on water? And the reason behind this phenomena is actually density. So, density is a very important topic in physics, especially in the unit fluids, because when you are learning about the properties of fluids in AP physics, we need to talk first about density. So, density is a fundamental physical property of any object, and it's usually given by mass per unit volume. So if you know the mass of any object in grams or kilograms, and if you know the volume of the object in centimeter cube or meter cube, the unit of density is going to be gram per centimeter cube or kilogram per meter cube. So now we are going to talk about density in a fluid. Fluid is a substance which flows. So it could be a gas or it could be a liquid. Now, the difference between gas and liquid is in gas, the intermolecular space is quite large compared to that of in a liquid. So, therefore, we can say that gases are compressible and the volume of a gas is easily increased or decreased. So, if you can change the volume of a container that has the gas in it, naturally the gas will be occupying the volume of the entire container. So, the volume can vary. But that's not the case for a liquid. If you are pouring the liquid in a container, whatever volume it has, it will remain almost fixed. It's not going to change. So for a liquid, the density pretty much remains constant because the mass is remaining constant of the liquid as well as the volume. But if you are considering gas, in this case, so gas, as we know, since the density is defined as mass per unit volume of any object, so you can see for a gas, the density will be totally dependent on the volume of the container because the mass usually is considered constant. So if you change the volume of the container, the entire gas will be filled inside the volume, and based on that, its density will be reduced or increased. So smaller volume will be having more density for the same gas, for the same amount of gas, and bigger volume will be having less density. All right. Now, if you observe the structural differences between gas, liquid, and solid, you can see how the molecules are vibrating. Now, specifically, this motion of the molecules inside the gas is called Brownian motion. And as you can see, the molecules are all colliding with each other, which is a perfectly elastic collision. And they're also colliding with the walls of the container. But for a liquid, although the molecules are vibrating over there, but they're not actually filling the entire container, they are colliding with each other. But they are, I mean, the molecular space, intermolecular space between those molecules is comparatively very, very less as compared to that of the gas. And for a solid, you can see on the right hand side, on the extreme right hand side, for a solid, the space is very, very negligible. So pretty much the entire molecules, all of the molecules are kind of fixed in their own respective spots and they're vibrating over there. So that's how the structural differences are between solid, liquid, and gases. So as mentioned earlier, you can see the mass density for any object or any gas is basically the ratio of the mass per unit volume. Now this particular symbol, this indicates density as well. So you can use either D or this specific symbol which is called rho. So we call this symbol rho, R-H-O. So rho is one way of expressing density. That's the notation for density. And as you can see, it's mass per unit volume. So the unit of mass usually in the SI system is kilogram and volume can be represented as meter cube. So we can write the unit of density is kilogram per meter cube. So different objects or different substances have their own densities. So you can see gasoline has a density of 680 kilogram per meter cube, which means that in 1 meter cube of gasoline, there is 680 kilogram of gasoline present. Now, density is highly related to floating or sinking of an object. Anything which floats must be having less density than the liquid on which it is floating. So the density of the substance decides if the object will be floating or sinking. For example, if you pour oil in water, you will see that the oil will float on top of the water, but as the density of the oil is less than the water. But if you think of corn syrup, it would actually sink inside water. So in this picture, you can see the oil is on top of the water, but the corn syrup is at the bottom of the container, whereas the water has occupied the space above the corn syrup. And this is indicating that the density of the upper liquid is less than the density of the lower liquid. So the same phenomena applies even for balloons. So if you think about a balloon which is filled with air, now the moment you are filling the balloon with air, if there is just air, there is air outside as well. So this balloon is just occupying this specific amount of space, and there is air inside as well as outside it. So in that case, the balloon is not going to go up because whatever density it has inside of the air, the density is going to be same outside. So this entire phenomena, this situation is basically called neutral equilibrium, as if the entire the balloon carrying the air having the same density is kind of floating or at rest, you can see, or static rather, I mean, with the outside air environment, right? So it's not actually going to go up because there is no other uplifting or any kind of upward thrust happening on this balloon. But if you think about a balloon which is carrying a gas having lower density than that of air, for example, helium. So you may have seen that certain balloons are actually just going up the moment you release them. And those balloons have to be filled with a gas which is having less density than that of air. And that is why we fill them with helium, because helium has less density than that of air. So helium filled balloons accelerate upward in air, whereas air filled balloons accelerate downward. So density of helium is less than density of air, and that is the reason it goes up. And why does it go up? Because if you consider a balloon having helium in it versus the air outside, so just because helium is lighter and air is, of course, heavier, the air is going to create an upward force on this particular balloon, which will push it upward, and this upward force is called buoyancy. So therefore, we can conclude that an object will float or sink within a liquid if its density decides to do so. So basically what I am trying to say is, if its density matches exactly the density of the fluid, then you will see that the object will be in a static equilibrium. That means it's going to be floating in it. But if you see the object is actually sinking, that means its density is more than the density of the liquid in which it is immersed. And that is why it will ultimately go down and it will go to the bottom of the container. So if the densities are equal, the object is in static equilibrium. Now, static equilibrium means it's kind of motionless and it's just hanging there, it's floating there. This is called neutral buoyancy. And remember, once again, the buoyancy is basically the upward thrust on the object which is immersed inside the liquid. And this upward thrust is created by the displaced liquid, and that displaced liquid is because of the object occupying the space inside the liquid. So as it sinks inside the liquid or as it is immersed inside the liquid, it's displacing a part of the liquid. So this volume of the liquid, as you can see in the picture, this volume of the liquid is actually displaced to the side, which creates an upward force on this object, and that is the buoyant force. So steel is denser than water, so it sinks. Oil floats because water is denser than oil. So as mentioned earlier, an object sinks if it weighs more than the fluid it displaces. That is, if its density is greater than the density of the fluid. So you can see over here, this is the This rho average is basically the density of the object, and this is the rho F, which is indicating the density of the fluid. If it is greater than that, so it's going to sink, and the object is going to rise to the surface if the density of the liquid is more or fluid is more than that of the density of the object. So there will be an upward thrust, and that thrust is going to push up the entire object upward. So density is a very important thing to decide whether the object is going to float or sink inside a liquid. And I hope this video has made it very clear to you. Let me know your thoughts. Thank you.